now we're going to do Anova. So I know we covered this topic like really long time ago, so let's just go through it really quick. So what is Anova? Anova is analysis of ovariance, so that's ANOVA here. So what does it do? Do you remember we are doing t-test statistics? We're testing 2 if 2 is equal. And here we are testing if the population means are equal. Yeah, that's the same thing, but we're testing more. It's more than 2 now. So an alternative hypothesis is this one. Okay, let's choose a bright color so you can see everything. So here, the non-hypothesis is going to be all of them are going to be the same. And the alternative is going to be one of them is different. So you can say at least one is different or at least one pair is different. It's kind of the same thing, right? So at least one is different. If all of them are 2, at least one is different. This is 4, that's different. Or at least one pair. I'm just going to say 4 doesn't equal to 2. So this pair is different. Yes. So K is the number of groups we're comparing. Before we do it, there are conditions, right? Like all the tests, there are conditions for ANOVA. What is the conditions for ANOVA? That is 1. Should be 1. It should be K independent populations. The second one is the population. Second one is random samples from each of the K groups. It's random. It doesn't mean that the group status has to be randomized. Just random samples from the population. The third one is large samples and greater than 30 or normal population. And third one, and the last one is equal population variance. So sometimes these are assumptions and this is condition, right? But if you are asking for conditions, you say all of them. Next one. So this data command for Anova is here. So this is a bar chart, and this is separate bar chart. This you can for. Sorry, I don't think the separate works like that. So separate bar chart for each group. This one, and separate bar chart for each group. Oh, this is over, and this is by. Okay, and this is Anova, the test review. Okay, so this is the test where we're doing ANOVA. This is one of ANOVA here. So this is this is test statistics, and this is the p-value. And so as we can see, when we're doing ANOVA, it automatically tests if the variance are equal. We always assume. Look at this page. We always assume it's equal population, right? Okay. Right. While we're at it, let's talk about this test statistics. It's F test statistics. So this is just basically the thing we are testing. It's an F distribution. So here is the table. I think this table is probably gonna be on the exam. So maybe this number is gone. You have this one and this one. How can you calculate this one? This one equal to this one over this one, right? So this is A, this is X, this one is X, A over X, and this is B, this is Y, this one is B over Y. And this F test statistics is this number over this number. It's quite simple and easy, right? So total is you sum this two up, and this total is sum this two up. So decision and conclusion. So when you are doing interpretation, there are always 2 parts. Decision and conclusion. Decision is like you reject it or not reject it. Conclusion is what conclusion you're gonna get. And then ANOVA and 2 sample t-test. So what is the difference between ANOVA and the 2 sample t-test? ANOVA equivalent to some 2 sample t-test. So ANOVA equivalent to 2 sample t-test with pooled variance, right? Because there is no difference in the variance. But it's different from 2 sample t-test with unequal variance, right? So the result may be different. So here, the intuition between ANOVA. So there are 2 paths of variation when comparing it. One is the group effect, one is individual effect. So let's say in group 1, I'm not going to draw all of it. In group 1, there are 2 points, and in group 2, there are 2 points. So let's say green group and purple group. So the individual effect is this green point. This line is the mean for the green group, and this line is the mean for the purple group. So individual effect is from this green point to this green line, and the group effect is from this green line to this blue line, which is the total mean. So all this is everything. This is all the difference, and this is the individual effect. This is a group effect, and then this is all the difference we're making here. Okay, so after you are doing the ANOVA, you will reject the null hypothesis. You know there's something different. So which one is different? You want to know that. How can you do that? You can do a post hoc comparison, which is the comparison where you're gonna find out which one is different. So there are three types you're gonna do. One is Bufferoni, another is Shefei, and then Tukey. It's not Turkey, it's Tukey. So you're thinking like, why can't we do like paired t-tests, like do a lot of pairs? First one is there. If you're comparing 5, then you're gonna do like 10 times. It's really a lot, and you need to control to have one error. So how you're gonna do is you can install this package. How you're gonna install it? First, you type in find this one or find this one. Sorry, find this one like this, and then you're gonna click this link, and then in the right box this one, and then you're gonna say install. Click here to install, and you're gonna do the same for Tukey HSD. After you conduct this one, let's see here, the p-value is smaller than 0.05, so it's significant, it's different. That means not all of them are the same. So I'm gonna choose a post hoc test. I'm gonna do a post hoc test. Oh, last homework. This one is not significant, so you don't have to do a post hoc test, right? Yeah. So here, this is Bufferoni and Shefei. You can say this is Bufferoni. I didn't really print everything. The Bufferoni and the Shefei. So the p-value here, you can see this one is smaller than this one. All of this one smaller than this. Oh, this one is greater than this one. Well, but basically the conclusion is going to be the same. So it's going to be this one is different than this one. So so far, what you need to know is kind of just a fun fact you should know is Shefei is more conservative than Bufferoni, and Bufferoni is more conservative than Tukey. So Shefei, Bufferoni, and Tukey, they're like, this one is really easy to reject you. This one is less easy to reject you. This one is less easy to reject you. So basically like that. So here, either way to specify pairwise. So you can specify the pairwise comparison result. This is a ladder plot, this is a star plot. Yes, so this is everything I think necessary to know about ANOVA, but I'm not really sure if this is gonna cover everything at the exam. But I hope this one helps you to review and give you an idea of a big picture of why we're doing ANOVA, and how are we doing it, and how are we gonna interpret it. And I would say this table, I would say this table is gonna be important. I will post this slide after, and I will do a recitation on Monday after class. So if you have problem, you can talk about at that time, okay? Awesome. Just calm down. I'm gonna do another review after this when I upload it. Okay. Awesome. You're doing fine. Just keep going. Awesome.